Hey folks, welcome back. Thanks to Looking Glass for sponsoring this video. We've done a collaboration with Looking Glass in the past. That time it was looking at one of their displays, the Looking Glass Portrait, which is a holographic display. This time we're going to be looking at a new product from them called Blocks. Blocks are an embeddable hologram that can be viewed anywhere on the internet. So they have a platform, blocks.glass, and we can see here that you can render them out of Unity, Unreal, Blender. These all have add-ons or plugins for them, and they can be viewed anywhere, so you can view them on the desktop, as I am here. You can also view them on a mobile phone, where the gyroscope will actually allow you to tip the block one way or other to give you the 3D effect. You can view them in VR if you've got a VR headset, and you can also view them on one of their holographic displays. So if you go to their website and you find a hologram that you like, you can view it directly then on your display, and it all comes through with the proper three-dimensionality that you expect. Now this tutorial is actually going to be 3 tutorials. We're going to have a look at how to do projection mapping. We're going to use fSpy, create a sort of a pre-textured corridor model. Then we're going to do a little bit of geometry nodes inspired by Mantisa. We're going to turn this into a sort of abstract point cloud with some interesting displacement around the camera. Finally, we're going to bring this through the Looking Glass add-on so that we can create a quilt, which is the name of the render that you do, that can be uploaded either as a block or can be viewed directly in a Looking Glass portrait. So without further ado, let's jump in. Starting off, I've just gone onto Unsplash, which is a free CC0 photo sharing platform, and I've found a nice photo that I like, this sort of looking straight down this colonnade. You can find any kind of image that you want. It's the best kind of composition for something like this. What we're going to be doing is pretty much straight on with a bit of perspective. That's what you want. Go ahead and download the image that you want to use. If you want to use the same one, there's a link in the description. Before we jump into Blender, we're actually going to be using fSpy. And fSpy is a way for us to compute perspective, essentially. It allows us to calculate from the perspective of an image how that image and the camera should fit in 3D space. So it's very easy to use, and we'll just run through it really quickly here. You're going to want fSpy. You're also going to want to use the fSpy Blender plugin, which you can just download the zip here. Again, links in the description. When you open fSpy the first time, you're going to be greeted with a screen like this. Just go ahead and drag in the image that you've downloaded. Now in this case, we only have one vanishing point, and we can kind of ignore all of the other perspective because the camera is so straight on. So up in the top left, we can change our vanishing points to 1. Now we just have a green line for our horizontal and 2 red lines for our converging points. What you need to do is just drag around your points until you've lined them up. If this is too dim for you, you can always turn off dim image. I always find this a little bit easier to work with. And we're just going to set it up something like this. I'm just trying to line up on those edges, and I'll do the same on the other side. Something around here should be fine. And last one, got to make sure you get your horizontal. I'm going to go from the corners over here down across there. Now, if you want to check this, use a 3D guide here. I'm going to just bring in a box. I'll drag it around the scene just to make sure that my horizontals all line up where I'm expecting them to. And we seem to have everything looking pretty good. Nice. This axis here, we are Z down, so we might need to flip this once we actually come into Blender, but I'm just going to put this, the center of my world is going to be just on that intersection, just there. This isn't particularly important for what we're going to be doing, but I like to just do that anyway. Next, all you need to do is just save this file. So go File, Save As, and I'm going to save it in my project file here for Corridor fSpy. Finally, we are in Blender here. I'm using Blender 3.3. You might find that the fSpy add-on doesn't play so well with 3.4, but again, your mileage may vary. Once you've got the fSpy add-on installed, you'll be able to import an fSpy object. I'm going to go for my corridor fSpy there, and I'll just import it like so. So now you can see that we have a camera object, and it has a background image set, and we can see that it has been positioned somewhere in our world with the perspective set. So if I was to go ahead and just add a cube object now, then you can see as I move this around, it kind of lines up with everything. It fits anywhere that we want it to in this corridor, right? So I'm just going to go ahead and delete that. Let's move our camera into the cameras collection, and we're going to start our projection mapping. It's a very easy process, but definitely worth knowing. Shift A, let's go ahead and add a plane object. And everything is very big at the moment. I might just scale things down towards the middle. This corridor is probably let's say 2 meters across, which would make this plane the correct width for the corridor. Obviously, right now it's a little bit too big. I want to make sure that everything is scaling towards our origin position. So let's go ahead, press period, and we're going to pivot towards our 3D cursor. You can also find that up here. Select everything, scale, now it goes down towards that. In this case, I'm going to leave my plane where it was, and I'm just going to scale the camera down instead. So let's go into camera view, scale down towards this plane, just until it feels around about right. That should fit there. It's around about 2 meters across now. Okay, so now the scaling's done. I'm going to go into my modifiers here, and we want to do a couple of things. We want to assign the image texture to our plane object. So let's create a shader editor, new material. Let's call this one projection. I have the node wrangler enabled, so I can select my principal node, press Ctrl T. This is going to give us an image texture. Our image is already in our camera, so it's in our scene. So we can just grab this like so. Let's go into material preview mode, have a look at what we see. All right, so not perfect right now. It's just mapped as you would expect it for a UV. We need this to actually be projected. I'm just going to make that emissive just so that we're going shadeless. And I'm going to change the texture coordinate node to a UV map, just so I can be a bit more prescriptive with which we are using. Let's go ahead and plug this in, and we'll just pick our UV map. In our object data properties, the green triangle, we can find our UV maps, and I'm going to just rename this one to proj for projector. Make sure you're picking it in your UV map node. Add a modifier. We're going to add the UV project modifier. We're going to assign the UV map that we've just set, and we're going to say that our object for the projection is corridor fSpy. It's going to give you the options of any object in your scene. In this case, we're specifically wanting the camera that we imported. Now, if I just make this a bit longer, let's drag this out in the x-axis down to the end of the corridor there. All right, that's not really looking perfect. If I extrude this up sideways as well, yeah, not great. So what's going on here? This is to do with subdivision. It's kind of mapped correctly actually, but just because of the lack of topology, it appears to be stretching outwards. So add a modifier, subdivision surface. I'm going to place this before the UV project, set it to simple. I'm going to increase this to maybe 5, looks pretty good there. Now you can see that this is actually not really mapping correctly. If I just fill everything there, then this projection isn't quite right. So what's wrong with it? Well, it's to do with our aspect ratio and our scaling. What I want to do is keep my scale Y to 1, but scale X needs to come down until we are, and you can just eyeball this really. You can do the maths if you want to. You can divide the short dimension by the long dimension. The camera's already been set up, so it's going to be 3700 by 5500 approximately. For me, I'm just going to zoom in here and just have an eyeball. There we go, that's fine. And now we can just come back and start modeling. So that's what I really like about projection mapping, is it makes this whole process very, very simple. What I can do is I can just scale this one out in the x-axis, make sure I'm going back to my median point transform. There we go. So now I'm wider than my columns. I can shift right click to drop down my 3D cursor, and then I can just add new objects like a new plane, which can become my column. So I'm just going to position this like so, position these until they match. And you don't have to be too picky with this. You can just literally extrude things until they fit. What we're going to be doing later with geometry nodes is fairly rough, so you don't actually need to be too accurate with this step. It just needs to be pretty much on the objects. So you don't have to just watch me doing extrusions in real time. We're going to speed this a little bit up here. Alright, so we've got through most of the modeling at this point, and you'll notice that I don't have anything at the end, and I also removed my final column here, and this is just to make the whole thing tileable. I'm actually going to go back into my camera view, and I'm going to remove the background image. There we go. And now what I can do as well is, if I come back into my object, I'm really interested in just knowing how long this is. And before we do this, I actually want to do a couple of things. I want to apply my projection modifier. If I reduce this, there we go. I'm going to go down to 3 levels on my subdivision, but I will just add a couple of manual cuts to my floor just to make sure there's no major sections which are unsupported. Everything else is probably dense enough without them. And then I can apply my subdivision and I can apply my UV project modifier. Now, when I move my camera around, or if I move my object, it's no longer getting updated. The UVs are properly baked into the surface now. This means I can do things such as scaling this, and I want to make sure that I've got it scaled up to some kind of round number. I'm not too worried about the floor overlapping itself, so I'm just going to go from here to at some point around here. Let's see where that actually is. Nearly at 10 meters. So let's just scale this up to 10. I'm going to put my cursor back to the world origin, scale from the cursor. I'm just going to scale it up until we just hit 10 on there. Apply my rotation scale. Now if I was to put an array on here, set to constant offset of 10. There we go. Now we have more corridor, and I can just kind of keep it going. Okay, so now there's just lots of corridor going down here. Always such a cool way of working. And you can sort of reproject things at this point, you know, like move your camera around. Some of these textures could really do with a bit of cleanup, but it works for what we're going to need, which is going to be abstracting it through points. So I'm not actually going to do my array here. We're going to do this in geometry nodes. Full disclosure, this is a process that I pretty much picked up from Mantisa, so props to him for coming up with this. I've gone into my geometry node setup here. I can see that I have some back faces showing, so I'm going to just select everything, tap into edit mode, select all, Shift N. That's pretty much got most of them, but these sections and these sections, let me just select all of these. I'm just pressing L here, and then if I accidentally selected too much, I'm going to Shift L. There we go. And then I'm going to do Alt N flip. And there we go. Just to make sure this is all facing inwards. It doesn't really matter for what we're doing today, but it's just kind of a force of habit, trying to make stuff look the correct way for the camera. I'm going to turn off my wireframe, don't need that. And we're going to just start off here. Make sure you're saving as you go here. Let's add a new node tree. We're going to be distributing points on faces. And that's most of what we're doing. We're just going to increase this to somewhere reasonable. Around about 200 is probably a good start. And if we go into rendered view here, into cycles, not looking amazing. Let's go and just set a material on these points. Let's use the projection. There we go. So straight away our points, because they're based on our faces and our faces have that UV map, they'll just take the same UV map. So that's going to work absolutely fine for what we need. I'm going to set my point radius. In here, we're going to go a little bit smaller, just so it feels like more of a point cloud. You can always make this denser as well if you want. If I made this up to like 1,000, then you'd have something that feels a bit more like photogrammetry, which is always kind of fun. And we can also set our world to be just off. There we go. This is looking pretty great so far. What I want to do is actually have an empty, go ahead and add an empty sphere. And this is going to be our sort of controller. This is going to, everything that is near this is going to be resolved. Everything that is far away from this is going to explode. Let's grab our empty into our project here. Let's set this to relative. That's important to make sure that we're using world space, not local object space. Just make sure everything like updates. And then we can do some pretty simple stuff actually. So we're going to be working just after our set material here. Go ahead and use a geometry set position node on here. I wonder how many points I've got actually. Not too bad. 250,000, that's probably all right for points. Points don't really take a lot of memory to process. So we want to know how far each point away is from our empty object. Use an input, position node, set this one to distance, and we'll plug this from the location of our empty and the position of our points. Put this through a map range node so that we can now set our distance limits with our from min from max and the effect of the displacement with our to min to max. Nice easy way of working. When we're working with our looking glass portrait displays, you can use videos and things like that. So nice and easy for us to just render out an animation from Blender, plug it into our holographic screens. If you're using the block platform, currently only static images are supported, but I believe there is a plan for videos in the future. So I'm going to go with the assumption that we're doing a video here, and we're going to animate the camera flying down the corridor and everything kind of exploding as we go past it, sort of resolving as we come towards it as well. So a little bit of animated displacement is going to be what we want. Animation's super easy. Let's just use a noise displacement here, noise texture, and a scene time node from our inputs, scene time. And first of all, we want to grab our noise texture. Let's do a little bit of simple displacement. We're going to go for a color displacement, so RGB. We have RGB values between 0 and 1, so we need to subtract 0.5 to center it. We can then scale this by some amount, and this amount is going to be coming from our empty, like this. So the distance from the empty goes into the scale of our displacement, and I can plug this then into the offset here. Right away we see this does change a little bit. If I move this around, nothing really seems to happen until we get close to something, and you can see that there is having a bit of an effect and sort of pinching stuff together, but it's not significant. What we actually have here is a map range that is clamping everything outside of the 1 meter radius. Let's turn off clamp and it should make everything kind of fly off into the distance there. And I also want to make sure that my sort of resolved area is like a bubble of, let's say, around about 2 meters, and then our fall off distance can be up to, say, 4 meters. We're not clamping, so it'll keep going. So let's go 2 to 4. And we do definitely want to clamp at 0. So I'm going to put on a math node set to maximum. And I'll just make sure that 0 is the lowest that we go down to. If I mute that, you can see that because we're not clamping, we have this essentially like a 2 to 4 distance being mapped to this 0 to 1. But because there's no clamping, it's just going to extrapolate in each direction. We need to make sure, therefore, that we're doing this maximum so that we can clamp the bottom section. So any value which is 0 or higher is going to make it through. That means, where's my rendered here? It means that this section is all nicely resolved. It's all points on the surface. And then as we go away, we get these kind of exploding points. And we can actually scale this up if we want to. Or better still, let's use a power node. So let's go with power. And we're going to go for power. I just set this to 1 just so I kind of know what I'm doing. So 2 is going to be squared. And you can see that we're just basically just destroying this. And that's exactly what I want. So as this empty moves through, and the camera is going to be parented to it, you can see that that has a very significant effect on our mesh. On our points, I should say. So that's fun. We can always change our values as well in here. Let's maybe bring the fall off down a bit closer. Somewhere like this, maybe 1 to 3, give or take. It's all personal preference, totally depends on your model, depends on the scale you're working at, just to find a value that you think works nicely. I just want to make sure that I have at least both sides of the model sort of intact around the camera. Now we could stand to have more points. It's going to get a bit heavier though, but if I was to go to something like 3000, it just gets a lot denser on that surface. If you were to also want to have shading on here, you can go and set your material here to use that principal BSDF. If you're doing this, you're just going to need to make sure you've turned on some kind of world here. I'm going to just use a texture, sky texture, into the color of my background node, Set my strength to 1 here. And there we go. I do actually want the black background, so I'm going to add another background node, which I'm going to set to be off. And I'm going to mix these with a mix shader, which I will control with a light path node set to isCameraRay. isCameraRay basically just gives you a yes/no answer based on whether or not what you're looking at is coming direct from the camera. So it's not looking at sort of bounced rays or anything like that. It's just directly what do you see. And if it's the light information or any kind of reflection or bounce, that's going to be coming off the sky texture, the now 0 socket, and the black background where the strength is 0, that's coming off our yes socket. So now you can see we're actually getting a little bit of shading in here. See if I move my sun around, you get a bit of that effect. So that's nice. We can actually relight this scene. Obviously it was very washed out, the original photo here, very overcast. So it's very easy for us to just inject some sunlight into this. Super fun. You can always increase your point radius if you want it to be, again, a little bit more intact. This is looking pretty cool. Renders super fast as well. Cycles is great with these point renderings. So let's continue on. How do we make this animate? Because right now it's just going to sit still like this. But if I want this to be looping, so not just an animation, but a looping animation, we need to work out some things. To get our noise to animate, we're going to be doing a little trick with some sine waves actually. It's a nice easy way to loop things and make sure that you can match up your first and final frames. We're going to need 4D noise, and we are going to need a vector that we create ourselves. So we're going to need a combine XYZ for this. And this is going to be based on the position. So let's just grab a position node, bring this one back. And this noise is actually technically 2-dimensional. So let's grab a separate XYZ. And we're going to construct our own coordinate space here. So we're going to put our X through a sine wave. And also, Control-Shift-D there, we're putting X through a cosine. This becomes our new X and Y. Next up, we need to do the exact same thing with the Y axis. So Control-Shift-D there. We're going to be just plugging these two into our Y axis. One becomes our Z. The other one becomes our W on this 4D noise. So this is our standard looping system. We can now just add some value to the position. Let's use a vector math add after our position. We're going to be putting our frame here through a map range node. And right now we have frames 0 or maybe 1 to 250. Yeah, 1 to 250. So I'll plug that in like this. So now we have 1 to 250 being 0 to 1, and we can add this combine XYZ. Let's plug this into our X, and we'll just be moving the X axis here for our noise. Let's just change our timeline settings so that we're not like a slow FPS here. What we want is to make sure that we are setting our sync to frame dropping. This will now just skip frames if it doesn't have the processing power to compute them. And I will also reduce my count here down to something a little bit lower, just so we can actually see what's going on with these. See what happens when we hit the final frame. Let's see if it jumps. All right, it does. So we just need to make sure that we are doing some scaling in here as well. Let's grab another vector math node, set this one to scale, and we can type in here tau, because that's a wavelength. So one full sine or cosine wavelength is tau. Need to just reduce our scale on here. Now let's see how we do. And there we go. Now you can see that we're not skipping anything at all there. So 251 is the next frame. All right, now it's just for us to work out how we want these to actually distort. How much, how far. So we can go for maybe a little bit more in our power node here, just to get these blending off a little bit further. And maybe I can just increase this a little bit here just to be a little bit more interesting. Cool, so now if I was to move through this empty, you can see it has this kind of effect where it all explodes. The power is probably a little bit too strong. Again, maybe 1.5 there. The reason I'm turning it down is because we're about to do an array. So just before all of this happens, before our distribute points on faces, we want to create an array, which we can do in geometry nodes super simply, just with instancing on points, our main structure. So I've just got this here. Instance on points with a mesh line. We are going in the X direction, 10 meters per step. That's what we worked out before. And we can just set as many as we want. Do just need to make sure that we have realize instances happening after here. And there we go. Now we have actual geometry. So as cool as it looks, it's going to kind of blow up too much, I think, in the camera view. So at this point, we probably want to do a couple of things. We want to animate our camera moving through. So at frame 0, not frame 1, we want frame 0. We're going to position our camera, our empty. Let's just temporarily mute our final set position there. So I'm going to put it nicely in the middle so we get the best chance. And I'm going to put it in the object in the x-axis at 10. So it's just at the start of the next section. So we've already got one behind us. Let's keyframe this, so insert single keyframe. And now we're going to go up to the final frame, 250. And we can set the X location to 20 and insert keyframe. So now over the course of this, it's a little bit difficult to see with everything being white. The empty object is going to move 10 meters down here. Do need to make sure that we have, that was just Control Tab to switch from my timeline to my graph editor. And press Home, select everything, press T to go into your interpolation, and just set it to linear so it doesn't have any slowdown or speed up at any point. I'm going to press Control Tab to go back to my timeline view here. And now what I want to do is I actually want to just parent the camera to the empty. Let's go back into my camera and I'm going to just walk it forwards here until we find something that we like the look of. Let's turn back on our set position. We need to turn down our exponent, I think here, maybe just a little bit. And let's try turning up our distribute points. I'll go up to 1,000 for now. I'm just going to move through this space until I get to the opening where the empty is. Now what I can do is I can grab my camera, grab my empty, Control P, and parent it to the object. Now as we play, you see it's a little bit stuttery just because of the playback speed with cycles and all of these points, but we are following this empty as it moves through the space. And as it loops, if I go back to that first frame here, here we go. So during playback, you'll notice that as we come from one end back to the beginning, it just takes a sec to update there. It's not going to affect the actual animation. It's just sort of an artifact of the viewport. Let's reduce our point size 0.01. I think that looks a little bit better. Maybe a little bit. 0.015, something like that. And I also want to increase the amount here, 1500. Maybe a few more. Let's go up to maybe 2000. And then what I want to do in true Mantisa fashion, I'm going to add a volume. Now, how cool does this look? All of these little twizzles. You can see it's sort of repeating, and that's just because of the wavelength of our sort of looped noise that we've got going on. I'm going to make this fairly large. And I'm just going to pull along until we cover, yeah, I'm just going to cover everything. Go back into our object mode. And on our cube, rename this one to volume. And we can set an object shader on here, delete the principal BSDF, add a principled volume shader. And we can just reduce the density. You'll just need to update the viewport there to get the volume to draw nicely. So I'm going to set it 0.05, so it's not super dense. And then I'm just going to control my sun. If I increase the elevation, nice sunbeams coming through here. Just kind of catching on that. You can always add a little bit more density if you want more of these, or you could even add some mesh at the top if you want to sort of double up the amount of points that you're getting up there. The way we can do this nice and easy is we can simply go into edit mode on our plane object, our original object here, tab into edit mode here, and I'm just going to select these top faces. Shift D, move them up. And maybe I'll just do that twice there. Turn back on my geometry nodes. And now you see we've got a little bit more density, which is really just what we need. So this is how we can create a fairly simple little bit of motion graphics flying down a corridor as it sort of builds itself around us. You can push these as far as you want in terms of the effects. With geometry nodes, it's all just points, so it renders nice and quick and you can kind of throw it about. The next part of this is going to be getting this into a block, and the process is actually super simple. Looking Glass have made it very easy for us to work with their products, so let's jump in here. What I would like to do, here's everything, is I'm going to need to install the Looking Glass add-on. You can find this add-on under the lookingglassfactory.com/software downloads. Scroll down until you find the Blender add-on. Come in here, and then you can find download on GitHub. It's just a standard add-on here. So just go ahead, grab that zip file, and then install it. When you first install the add-on, you'll be able to find it under Edit, Preferences, Add-ons. And when you enable it, it's going to say Install Dependencies. Just go ahead, click this, it's going to pull down a few libraries that it needs, and then it'll work. Now, if you do have a Looking Glass portrait or one of the other Looking Glass displays, you're also going to need the HoloPlay service, which I believe is now called the Looking Glass Bridge. And this is basically just a communication between your computer and the displays themselves. This is something that you need if you want to view blocks when they load on the internet on your device directly. But if you just want to use blocks and use them in the browser or use them on your phone, then that is optional. Before we jump in, we do just need to restart Blender for the changes to take effect. And we're back. So Looking Glass now shows up in our end panel as an option. And we need to do a couple of things really to get this working. So I already have a camera in my scene, but if you didn't, you could just click the plus here on the add-on UI. I'm just going to set mine to this camera. Most things disappear at this point, and this is always a little bit worrying. This is actually to do with our clipping range. One of the things that happens with this sort of parallax holographic method, rather than it being like a true volumetric display, we're just dealing with a sort of lateral parallax. So when you have things that extend right up towards the camera, they can sort of swing around, and the same into the distance. In this case, we do actually want the depth, but this clipping distance that we can see here, you can see we've got a clip start, clip end. I'm just going to bring this back so that I've got everything I need. I'm going to come pretty close here, about 1 meter, and clip end we can make kind of wherever we want. These can look a little bit noisy when you go too far away, but in this case, we do want it to go all the way to where it's sort of obliterated the detail. The focal plane is where we tip around. If you want to have a little bit of a preview of this, In the top right, we have this drop down. I can increase my scaling factor, and I can maybe reduce or increase the alpha depending on how I want to view this. As I mouse over it, it behaves like a block does, and you can get a sense of how much swing you're going to get. Now, if you pull the focal plane back towards the camera, then it's more like the camera is looking from side to side. This works all right for blocks, but it's actually quite bad for the looking glass displays. So I would recommend, if you want this to be a bit more multifunctional, then I would recommend having your focal plane just a little bit further away, and maybe change your clip start just to get rid of some more of those nearby things which actually swing into the view. So that's looking pretty good for me. I quite like this. Unfortunately, these blocks are not visible in rendered view, but that kind of makes sense. You're sort of simultaneously rendering 48 views of your object. Now, in my case, I do actually have a looking glass portrait plugged in, so I can click this icon in the top here, and it's going to load it straight onto my device. So when we click that button, we can view it directly on the device, and it's going to all load in nicely for us. And we can get a sense of how this is going to look in 3D. Of course, we are just using the viewport rendering at this point. What we really want to do is actually start setting up a render. So as we come down the UI and the add-on here, we can see quilt setup and rendering. What is a quilt? Well, a quilt looks something like this. So it's a quilt because it's essentially a grid all stitched together. These are the different views that we have, and we're basically just switching between them as we rotate around. So I could just set this to use device settings, which will use whichever the plugged in device is. In this case, I want to be rendering a block, so I can actually render something that's a bit higher resolution. So I could set this to be, for example, one of these 4K Gen 2 looking glasses, which are a horizontal larger display. Or you could use, one of the 8K looking glasses instead as your preset. I'm going to stick with the looking glass portrait. I quite like the aspect ratio, especially for something like this where we have the corridor. And then for the quilt, I'm going to actually set this to be a 4K 45 view quilt rather than the standard portrait 48. Now we can output either only the quilt file or the views, like the individual renders as well. I will do that in this case. And I'm going to make sure that I'm also rendering with my volume. I want to see that. Now everything else is actually going to come from Blender's settings. So I'm using cycles to render. That's what's going to be used. I'm going to set my sampling, because I do have a volume in here. I'm going to set my sampling to have maybe 256 as my max sample, something like that will be fine. I am, of course, denoising. And then in my output settings, I'm also going to just save somewhere where this can go. So I will set this to PNGs, and I will create a new directory in here for corridor quilt, in this case 2, because I already did a test. And there we go, I've given myself a default name there, which will have the string appended to the end of it. So let's accept that. Go ahead and save this. Being Blender, being add-ons, and being rendering especially, it can sometimes crash mid-render. The add-on has a really great way of picking up if it cancels mid-render, if it crashes. When you reopen, it'll have a little icon here on the display where you've got your progress bar now that will say unfinished quilt render. Would you like to continue? And then you can just continue from that directly. So nice and easy if it does cancel on you. We're just going to let this go through. It's going to do 45 renders for us, and it's going to stitch together the actual quilt. Let me see these starting to come through here now. There we go, that's finished rendering. It does 45 of these individual images, and we can see it's got a string attached to the end, QS5x9A 0.75. This is a 5x9 grid. Therefore, it's important that this is in the file name, so don't change this file name if you do make one, because you've got to have a way to basically read. Okay, it's going to be a 5x9 grid, and with an aspect ratio per image of like 1 to 0.5. Now we can actually use our light field window. If you do have a looking glass portrait or similar, you can set this to quilt viewer, and you can actually view your quilt result directly in your device at this point. So let me just bring this up for you. You can see that we do now actually have our render. This is our full corridor. This is going to look a lot better, I think, as a block. I'm really excited about blocks because they allow these holograms to be ubiquitous. You can view them on your phone, on your VR headset, you can view them in the browser, you can share them with friends, you can embed them on Twitter. Let's have a look at how we can upload one. If I go into the blocks page here, you will need to sign up for join the waiting list. But once you're in, you can just click the plus in the top corner. We're going to need to drag and drop a hologram. There we go. And we'll just wait for this one to upload real quick. And it'll do a little bit of processing based on things like the name, just to set up the hologram for us, the block. Once it finishes uploading, you can get a preview of your hologram. You have the debug happening on the right-hand side where you can see which frame you're looking at. And you can just swing it around. So you do get a little bit of ghosting happening, and that's just natural when you have such deep perspective. In my opinion, some of the best ones of these blocks, and we'll have a look in a minute, are the ones that have a little bit of a shorter range of visual interest. I just really like the perspective depth that you can get in these. Let's give this one a new name. We're going to give this one point corridor. 5:9, that's correct. Aspect ratio, this is correct. So if you had changed the name, you could just put in the values that you know to be correct. And I can click save and publish. Once it's saved, I can go to that page. And as soon as I do, I see that it's loaded on my device, on my Looking Glass portrait. Also from my library, I can copy a link here. So this is going to take me to the actual page, at which point I can load this into something like Notion, create an embed. And now you can see I have it on my Notion with my others in here. So some of my others that I think work really well as well are going to be things like this kitchen scene, where we have a very short focal plane. It's a very limited depth. Similarly, in this bathroom, there's certainly bits of it that swing around a lot, but the main focus is quite contained. And again, on this still life, we have a fairly contained section of visual interest. You can see that you can even get them embedding on Twitter here. So very cool tag. I'm really excited about this as a new means for us to be able to show off some of our 3D work. I'm really excited for when they start supporting videos in Blender. The only difference is that you will be clicking render animation quilt instead of render quilt. Otherwise, it's the same process exactly. If you're interested in learning more about Looking Glass, check the links down in the description below. If you want $40 off your own Looking Glass portrait, again, link down in the description. Huge thank you to Looking Glass for sponsoring the channel again, and as always, I hope you learned something, hope you had fun. I'll catch you in the next one.